Ah, the sizzle of McDonald's sausage. It's enough to make you crave your favorite breakfasts. Enough to head over to McDonald's. Enough to make you really wish this commercial were scratch and sniff.
And if you're a sausage person, now get 2 satisfyingly savory sausage McGriddles, sausage biscuits, or sausage burritos for just $3.33. Or mix and match. Price and participation may vary. Cannot be combined with any other offer or combo meal. Single item at regular price.
Ba-da-ba-ba-ba.
Hello once again, everybody. I'm meteorologist Sean Sublette, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has digital and print news operations in more than 70 locations across the country, including my home base in Richmond, Virginia. I'm joined this week by Matt Holiner in Chicago and Joe Martucci at the beautiful New Jersey shore. Kirsten Lang is out of the office for this afternoon. Joe, we're getting closer to Memorial Day, which is a huge deal at the shore. I know that. So summertime is coming. Are they getting excited at the shore, man?
Well, yes. The answer is yes, but we are a little worried because we have gone in the double digits, the number of weekends with wet weather. So we are hoping that we break that streak as we go into Memorial Day weekend. But I mean, listen, Sean, this is it's like Christmas. It's like the holidays for the Jersey Shore here right now. You know, if you work at the shore, you're waiting for the influx of tourists and visitors to come as your business really gets going. This is where we're making our money. If you live inland in New Jersey or you're in Philadelphia, you're thinking about now's the time to start packing up the car and heading to the shore. You know, I put up an Instagram poll on my Instagram account at JoeMartWX for anybody who's interested. And I asked, what is your favorite part about summer? And my 4 options were finding parking on the beach block, someone giving you their beach badge for you as they're walking off, because remember in New Jersey, you have to pay to go on the beach, Wawa at 1:30 in the morning, or the illustrious DJ's Club in Belmar, New Jersey. So if you're in New Jersey, you know all 4 of those things, you know what they mean, but it's here. It's coming. It's here. We're excited. We just hope it is dry for Memorial Day week.
You know, I know 3 of those things, but I'm getting to be an old man. So we'll move on to the next thing. Matt, I know your friends in Texas are really worried that it's going to be just torrid again this summer.
Yeah, it's really depends on where you live in the country, because I'm feeling like Joe. It's like, all right, summer is here in Chicago. People are excited and happy. Beach season in Chicago too, because remember, Chicago does have beaches, lake beaches.
Yes.
But boy, it's a different story in Texas. People are grumbling already, even though it's just May, about how hot it is, and they're like, oh no, we still got June, July, August. And so, yeah, the question I'm getting, from friends and family back home is it going to be as bad as last summer? Because last summer was just incredible. How many heat advisories, heat warnings, how many streaks of 100-degree days Texas periods, but really like southern U.S. in general. Because let's not forget about what happened in Phoenix and that incredible streak of 110-degree days. So those people are concerned too. They're not looking forward to this like folks farther north. They're bracing for, oh no, is it going to be just as bad as last year? So that's all we've got to talk about.
Yeah, and then just earlier this week, Florida had a heat wave. And yeah, Florida's hot and all, but down in Key West, they had a dew point temperature, for those who follow such things, 82. And they had a heat index of 115 here before Memorial Day. So it's hot, no question. Summer's a bit hot in the U.S., but over the last 20 years, I went back and looked at some data. We really reached into new territory. Of the 10 hottest summers on record nationally, going back to 1895, 8 of them have come in the last 20 years. So, as the climate warms, these hotter summers are going to get more and more numerous. But even so, there are still these fluctuations from year to year. And with that, we wanted to tackle the forecasting issue of monthly and seasonal outlooks as we go into the summer. Our guest this week is Jan Dutton. He's a meteorologist from Prescient Weather. Their World Climate Service consults businesses involved in agriculture, energy, and insurance, all of which very heavily dependent on weather and in a position, honestly, to save some money if they had a hint of what might be coming. Dutton got his PhD in meteorology at Penn State in 2000, and he has been deeply involved in the business branch of meteorology ever since. So we wanted to talk to him specifically about the summer outlook for 2024 and how we could even make these seasonal outlooks in the first place. So with that, here's our conversation with Jan Dutton. Jan, thanks for taking the time to join us today. right up front, when we look at how summer 2024 is going to play out in the United States, what is the data kind of telling us as to how it might differ from a normal summer?
Well, that's a great question, Sean. So what is going on right now is we just had an El Nino during most of 2023, and we're transitioning towards a La Nina, probably, which will be in place by late summer. And so looking at what has happened in the past when we've had a transition from an El Nino to a La Nina, it is generally warmer conditions east of the Rockies. We in particular are suggesting warmer conditions in the eastern third of the United States.
What about the west of through the Intermountain West and the West Coast? Any kind of signals there?
Yeah, so it's likely to be cooler than normal in Southern California at the start of the summer, and then warmer than normal around sort of the greater Rio Grande Valley or the Colorado River Valley. We're saying that we can expect dry conditions also roughly in the Colorado River Valley and dry conditions in the Ohio Valley as well.
Just as a caution, when we say things like wet and we say things like dry, we do mean with respect to normal. We don't mean to imply that it won't rain at all for 3 months in the Ohio Valley, right?
Yeah, that's correct. And I should also say one of the challenges of seasonal forecasting is there's no absolutes. That we as meteorologists want to talk in terms of probabilities, but to make it easily digestible, we have to talk about what's most likely going to happen. But in the background, there needs to be an understanding that a wide range of potential outcomes are possible. But really what we're talking about is what's most likely going to happen given the data that we have available to us.
Is there any other overarching data besides the transition from El Nino to La Nina? And for those not familiar, it's basically the water temperature in the central equatorial Pacific and how that is transitioning, which then feeds back to jet stream patterns. Are there any other signals out there that kind of jump out as to what the summer might be like?
We're trying to provide our customers and our own meteorologists tools that allow for a better long-range forecast. And so when we do that, we are looking at both the dynamical models, which you can think of as being like the weather forecast models that we use for the 3-day forecasts. They just happen to be run to months in advance. We look at what are called analogs. So when we talk about looking at what happened in the past from El Niños transitioning to La Niñas, really we're doing an analog analysis. We happen to have some statistical models that we use to try to extract signals from what has happened over the past, say, 50 years that we wouldn't otherwise be able to see from a more simple analysis. And so when we're looking at these forecasts, a lot of it is understanding what happens when the climate is in a certain state. There are a few other indices that we think are going to be important for the summer forecast. One is called the Pacific Decadal Oscillation. And so that basically describes temperatures in the North Pacific Ocean. So El Nino, La Nina is the tropical Pacific. The Pacific Decadal Oscillation is the Northern Pacific Ocean. And the PDO, as it's called, can have strong impacts on the U.S. climate. And so certainly we're looking at forecasts of the PDO as well. In fact, that's why we're suggesting colder than normal conditions in California, is because of the particular setup of the PDO right now. The other one that's really quite important is going to be that the Atlantic Ocean is definitely warmer than normal right now. And so that impacts the eastern U.S. coast mostly. So those are really the three primary drivers of the summer outlook right now.
And Jan, I want to do a comparison with last summer, because one of the big questions I've been getting from family and friends back in Texas, it was, of course, an exceptionally hot summer in Texas last year. I mean, tons of heat advisories and heat warnings. And so people hear, oh, another hot summer. Well, the question that then comes is it going to be as bad as last summer? So as a comparison, this summer to last summer across the U.S., what are the differences and how is it going to compare?
So that is a great question. And you are right. Last summer was brutal in Texas. And we're going to talk about subseasonal forecasting possibly a little bit later. And I'll just say that our tool, which was showing forecasts for 3, 4, up to 6 weeks in advance, was just showing warmer than normal temperatures throughout that period. So last summer would have been driven primarily by an El Nino type climate, which normally would be generally cooler than normal across the U.S. and generally wetter than normal. So again, we're talking about the difference between what normally happens during an El Nino and what happens during a La Nina. And so La Ninas tend to be hot across the Midwest and dry across the Midwest. And then what I just described, some of these other climate indices provide a little bit of nuances to the actual outlook and influence the final outlook. I will say our summer outlook does include most likely probability of warmer than normal temperatures across Texas. So Texas might be quite similar to last summer.
Yeah, and it's Joe. And another thing that I think captured many people's minds last summer was all the wildfire smoke that we had, especially in the Northeast and the Great Lakes. I'm not going to ask you to predict what the wildfire smoke is, but in terms of the wildfire situation with the fires that, we saw last year in Canada and we're seeing this year in Canada, I even believe in Mexico too, a number of wildfires. Is there something, are you putting out that kind of information in your summer outlooks, what the wildfire season would look like?
Yeah, so we do not put out that kind of information in our outlooks. I'll say we focus primarily on the factors that matter most to energy and really energy consumption or energy production. And so that's not to say that wildfires aren't important to the energy industry, because they certainly are. And in fact, we saw last year an electric utility shut down their electric distribution because of wildfire risks. But we tend not to focus on that.
So primarily, Jan, you look at Europe and North America. Do you do much of these subseasonal and seasonal outlooks in other parts of the world, or are you just kind of focused on those two areas the most?
So we provide our customers outlooks for Europe, North America, and Asia. And then part of the reason we're here talking is because we offer an online tool set that enables primarily meteorologists to make long-range forecasts. And we try to package, it's really just an unbelievable amount of information into one tool. And so while we don't make forecasts for other places around the world, like say Australia or South America, there's no reason why someone couldn't do it using the information that we are providing. So it's really a case where when we issue a monthly updated seasonal forecast, we're sort of eating our own bread. And the way our business works is other meteorologists can eat the same bread that we're making.
Jan, I'll try to ask you a question I think you'll be able to answer, because I know this relates a lot to air conditioning usage, and that is low temperatures at night. Do you break out how those overnight lows can be? Because I've done reporting here at the Jersey Shore about the increase we've seen over the decades of low temperatures in the 70s, even sometimes the 80s, and what that is doing for people's health and their electric usage as a result.
When we are making a forecast for, say, a month in advance or a season in advance or even weeks in advance, we're forecasting the likely change in the average temperature, right? So the average temperature is the average of the daily high and the daily low. So you get that for a day, and then you average it over, say, a month. So again, we're not making a specific call about the impact of nighttime temperatures, but I'm sure it's a safe assumption that if we're forecasting, say, warmer than normal temperatures, that the nighttime lows during that period will also end up being higher than normal because of the definition of average temperatures.
And then, Jan, in addition to the oscillations, do you just factor in at all a climate change into your projections? The fact that just in general, you take the oscillations out of it, we've just seen this steady warming trend as we go in the summer. So already, if you just take the baseline, the chance of a warmer than normal summer is higher than it was 10, 20 years ago. Is that something that you're factoring in to these forecasts?
Yeah, we definitely have to factor that in. The reason is that if you just take the temperature change signal over the last 30 years, your forecast for just about everywhere in the world is going to end up being a warmer than normal forecast. So, NOAA has a process of updating the 30-year normals every 10 years. So while we're not doing that type of process, we are absolutely considering the temperature trends when we are doing our analysis. And that's, again, it's because the trends are strong enough that they'll just swamp out any other signal. So we're definitely taking that into consideration. And then I'll also say, even when we're looking at the indices, it seems like some of the indices have long-term trends as well.
Yeah, so Jan, to follow up on this and how critical it is for a lot of your clients, energy, agriculture, insurance, a lot of people who aren't involved in those industries, if you think about it for a while, it kind of makes sense. But without giving too much away, what are some things that people who aren't involved in this in their day-to-day lives, are there 2 or 3 kinds of high-impact weather events that kind of go unseen by a lot of people in the United States that happen in other parts of the world that ultimately cascade down to what consumers are going to have to deal with here in the States. Maybe there was a bad heat wave in the wheat belts of Canada, or a deluge in China, or anything like that ultimately scales back into affecting people's pocketbooks here in the States?
That is a great question. Yeah, so I think that you just mentioned a good example, and I'll generalize it to say that sort of food security is overall lower just because of greater variability of temperature and precipitation. And so at any one location, it may be in a good growing year at any given time, but looking across the globe, there are more areas potentially at greater risk. And that just has the impact of increasing prices over the long term, just because of the potential for scarcity or the potential for volatility in production. One of the things that I'd like to cite, I remember a few years ago, I had tracked down a paper done by two academics from Yeshiva University, and they found that companies who operate in more climate volatile regions actually pay higher interest rates on their loans. And so their sort of theory behind it was that because that business's cash flows are more volatile because it's in a more volatile climate, that volatility increased the risk when the bank evaluated their cash flows, and the result was an incrementally higher interest rate. And so I think that, to me, I thought that was kind of fascinating, because it's the first time I had read about where weather variability directly impacted the financing of a company. And so that ends up flowing down into higher prices of companies that operate in more climate volatile areas. It also suggests that as climate becomes more volatile, that companies are going to end up paying more for their loans, on top of the already higher interest rates that we're experiencing now, and that will only drive prices higher as well. So there's definitely there's many just unseen impacts of weather on people and on businesses.
Yeah, there is a lot to unpack on very, very numerous levels. We're going to take a little break. We'll come back and talk more about how we do some of this sub-seasonal and seasonal forecasting with Jan Dutton of Prescient Weather when we continue on the Across the Sky podcast.
For years, you asked yourself, how do I save more money? But now it's, how do I preserve my money? Someone's asking the right questions. And at Sandy Spring Trust, we'll answer them one-on-one. From asset management to legacy and estate planning, you can feel confident in what's to come. What's your next financial destination? Visit sandyspringbank.com/wealth. Wealth and insurance products are not FDIC insured, not guaranteed, and may lose value. Wealth products offered by Sandy Spring Trust, a division of Sandy Spring Bank.
And welcome back to the Across the Sky podcast. I'm meteorologist Sean Sublette. We're here with Jan Dutton of Prescient Weather. Their World Climate Service advises and consults businesses on energy, agriculture, insurance, on weather risks and volatility. And in that, we think about the weather not just the next couple of days or a few days, but for several weeks, sub-seasonal and seasonal. Jan, so many times what we do in the regular day-to-day weather forecasting is what's the high and the low going to be 2, 3, 4 days from now? Explain what you're doing in terms of sub-seasonal or multiple week forecasts. We talked a little bit about this at the outset, about looking at a whole season being warmer or drier or cooler or wetter than normal. So talk about this kind of sweet spot in between where you're doing a lot of work now.
Sure. So when we look at the time scales of forecasting, we would call a traditional forecast as the time period or the lead time from, say, 1 to 10, maybe 15 days into the future. So that's the time frame that you can make what's called a deterministic forecast. You can say, as you said, day 5, the high temperature is going to be 72 degrees. As you get beyond that time frame of 15 days, what is colloquially called the butterfly effect takes over, and the chaotic nature of the atmosphere makes it impossible to create a deterministic forecast. But because there's a wealth of model data available and also analog data available, we can still try to extract the signal from the noise of all of that forecast information and make determinations of what is likely to happen, say 3 weeks in advance or 4 weeks in advance. And the reason we're able to do that is whereas a deterministic forecast is for a particular value, say on a particular day, we average over time. So A subseasonal forecast, for example, is for the 7 days that is 3 weeks in advance. And by averaging over time, over those 7 days, 3 weeks in advance, we're trying to eliminate noise and we're trying to extract signal. And there's actually a lot of data available to make a subseasonal forecast. And I'm gonna talk about a concept that is sometimes hard to understand, but many of the modeling agencies provide what's called a reforecast, where they take whatever the current model is and they run the model for days in the past. And in many cases, we get 20 years of reforecast data. And that allows us to look at how well the model performs, 3 days out, but also 3 weeks out. And so we take that information of how well the model performs, and it allows us to correct the real-time models as they're released. And it allows us to look at the probability of different outcomes 3 weeks in advance. So rather than say that it's going to be a particular temperature 3 weeks in advance, we're able to estimate the probability of temperatures being above normal or below normal. And then from that, our users are trying to decide what impact that might have and whether it makes sense for them to take some action to their business. So really, the summary is that we're able to do subseasonal forecasting in part because the forecasting technology has evolved to the point where we can extract the signal from the noise and gain some understanding of what might happen in the weeks and months in advance.
And Jan, I want to talk about the verification process because, when we're making a short-term forecast, you don't have to wait too long to see if that forecast is verified or not. But just like you're looking farther into the future, you also have to wait longer for the forecast to verify. So what's the verification process like? And then what do you learn through that process that you use in the future the next time you're making a subseasonal or seasonal forecast?
Yeah, that is a great question. So when we talk about verification of subseasonal or seasonal forecasts, we're talking about how well do the probability forecasts perform. So for example, we might say that the temperature 3 weeks from now has a 60% chance of being above normal. And what we want to happen, or what makes sense to happen, is that warmer than normal should occur 60% of the time. So what should happen is when you say 60% chance of above normal temperatures, it should happen 60% of the time. And so the analogy would be that when you look on the app that you use to see if it's going to rain tomorrow, and it says, 33% chance of rain tomorrow, it should rain 33% of the time that it says that. And so when we are evaluating the long range forecast, we're always making them in a probabilistic context because really the deterministic context is impossible. And so we're trying to determine if the forecasts are what are called reliable, where reliable is that the probability that we're forecasting the event should happen with that frequency. And then, so what we are doing is we are looking to see if the forecasts are in fact reliable. And then given that information, we can try different methodologies or basically different statistical ways of processing the forecast different, to try to make the forecast more reliable over time.
Yeah, going back to the verification, if I remember correctly, and correct me if I am not correct, correct me if I'm wrong, there was a pretty strong signal for that heavy rain event in Dubai a few weeks ago, was there not?
Yeah. We saw signals, say 2.5 weeks in advance. We saw signals for that. And I'll say just in general, Sean, there are times when there will be an event that makes the news, a flooding somewhere or a heat wave somewhere. And I will go look at our subseasonal forecast from a few weeks ago. And many times there is signal there. And again, it's not a ripping probability of 100% chance of above normal rainfall 6 weeks in advance, but there are definitely times when there's greater than normal chances of say a heavy rain event. So like one example that I can give is it was what for us is winter, but it was the Argentinian crop summer. And I remember seeing 6 weeks in advance, there was probabilities of warmer than normal temperatures. So maybe it was 40% or 50%. And then when you went from 6 weeks up to 1 week in advance, those probabilities just increased the whole way through. So that by the time we were at like 3 weeks in advance, the probabilities were 50 to 60% chance of above normal temperatures across much of Argentina. And what eventually happened was it ended up being a record-breaking heat wave, and it actually impacted the agriculture markets. So the price of corn was actually impacted because really hot temperatures are bad for corn. And so like we would use that as an example of where having that information 3 weeks in advance, you might actually be able to take advantage of that information.
Yeah, and to that end, so many times, even in the short range forecast, we'll look at how the guidance is trending. We'll see how the change in the model is forecasting an event or location in time as that time gets closer. Do you see a very similar situation there, as you alluded to the heat in Argentina, where it's like, wow, we see a small signal 6 weeks in advance, and then the signal's a little stronger 5 weeks in advance, and maybe a tiny bit stronger 4 weeks in advance. Is that analogy hold pretty well in subseasonal and seasonal forecasting, kind of like it does here in the shorter term?
Yes, it's directly analogous. And usually when the significant events happen, the heavy precipitation or a heat wave, or even I should say a cold air outbreak, there's usually signals weeks in advance, and the probabilities just get stronger as you get nearer to the actual event.
Yeah, so you're not going to see like 6 weeks out a big 70% boom signal, but maybe you see a 55 and it goes to 60 and then 65, and you see it trending in a certain direction. Yeah. So I'm assuming you have a lot more confidence 2 or 3 weeks out versus 5 and 6 weeks out, correct?
Yeah, although, so just we're going to get very specific, 55 or 60% chance 6 weeks out would be extremely unusual, if not has never happened before. So maybe it'd be 40% chance or something like that. But I mean, one example we mentioned earlier is Texas last summer, right? Texas was really, really warm all summer long. And so our probabilistic subseasonal temperatures for Texas showed high probabilities of warmer than normal from 2 weeks into the future to 6 weeks into the future all summer long. And I haven't had a chance to go back and look at like sort of what was driving that, what was driving the warmth and what was creating that high predictability signal. But it is a case where the information was in the models and they were correct.
And I'm curious about who's interested. I mean, obviously there's some interest at all levels, but at Prescient Weather, who are I'm not sure if you can mention any specific names, but what kind of customers are asking you and are wanting this information for forecast 4, 5, 6 weeks in advance? Who are your primary customers?
Our primary customers are people that work at commodity trading organizations. And so commodity trading, meaning power trading, gas trading, or agriculture trading as well. In particular for the World Climate Service, it is used by meteorologists primarily on power trading desks in the United States and in Europe. And they are using it basically to try to understand the direction that the shorter term deterministic forecasts are going to be, as well as just understand whether there's a strong signal of a warmer than normal or a colder than normal or a windier than normal or a less windier than normal situation. And the reason is, in the end, power markets, like any market, responds to market perceptions of supply and demand. And so very roughly speaking, temperature is a demand function because when it's warmer than normal or when it's really, really warm, people are turning on their air conditioning and demanding electricity for cooling. When it's colder, people are heating their homes, generally and many times through electricity or through natural gas. And then there's supply. So wind and solar now, because of wind power and solar energy, are also now directly related to power supply. And so that balance of demand and supply is driving prices. And if you have advanced information or better information than your competitor, you have an advantage over them in trading markets. I'll also say that we have a smaller number of customers, but like one really interesting application of our product, the World Climate Service. So the UN Food and Agriculture Organization Locust Monitoring Group uses our long-range forecasts of precipitation. So locusts generally sit dormant in dry soil, and when the soil gets wet, the locusts become undormant. And if they're not monitored and handled properly, you can actually have a locust outbreak. And so for those that are not familiar with locusts in, say, in Northern Africa, it can destroy a country's crop in like 3 days. So it's a very closely monitored natural disaster, basically. And our long-term forecasts are used to try to properly manage the risk of there being a locust outbreak. We also have, for example, the Danish Meteorological Institute, which is the National Weather Service Denmark uses us in preparation for their long-range forecasts. And then actually the Meteorological Service of Jamaica is also using the World Climate Service to help prepare their long-range forecasts as well. And so that highlights a whole nother application, right? We've been talking about commodities, but there is this concept called early warning systems, in which many organizations around the world want to have as much warning as possible of severe and disruptive events. And as we were sort of talking about, our tool, the World Climate Service, is sort of perfect for that.
Yeah, so as I expected, lots of people interested, lots of people coming to you for information. So how many people are on your team? If you've got all these people coming to you for information, how many people are at Prescient Weather and working on this?
How many do you think?
I'm going to say probably fewer than I'm expecting. I'm going to say it's a team of 15.
All right. We are 3 people. I do no science or technical work. I do all kinds of stuff like this. We're actually going to be 4 people starting on Monday. But I have to give a lot of credit to my colleagues, Richard James and Jeremy Ross, because they have created an absolutely incredible capability given the scale of our little business.
And Jan, just kind of going into yourself, right? I know you come from an illustrious meteorological family, but maybe not everybody knows that. Could you talk about how you got interested in weather and how you become such a force in this space and your life in weather?
Yeah, that's a great question. So my father was a professor of meteorology at Penn State University, and I can tell you, when I was a teenager, the last thing in the world I wanted to be was a meteorologist, and I had no interest in it. And I ended up going to college, and somehow in college I ended up doing a physics major, but I also did a science and technology studies major. So I went to Colby College in Maine, and I was very lucky that my science and technology studies advisor was a historian of atmospheric science. And so as a result, I actually was introduced really to sort of academic meteorology through my advisor there. And I ended up doing a senior paper for my science and technology studies major focused on paleoclimatology, which is understanding past climates. And then when I was graduating, I applied to graduate schools and I applied to jobs. I didn't get any job interviews. And fortunately, I was accepted at the Penn State meteorology program. I missed a key point, which is somewhere in my Colby career, Colby does what's called Jan Plan. So for the month of January, you do a class or you do an internship. And I went out to the National Center for Atmospheric Research in Boulder, Colorado for a month for January. And I helped their research King Air prepare for a research mission. That actually changed my life, because having done that, I was like, oh, this is awesome. And then that's when I came back and really got focused on science.
I would say a January in Boulder is pretty cold, but you were already in Maine, so you were used to it by then.
It actually was warm. Yeah, it was warm compared to Maine. It was a great experience.
Yeah, NCAR is beautiful. It's been a while since I've been out there, but I always love going to visit there when I have the opportunity. One final question before we wrap up, Jan, and I'm not sure how much of this y'all do yet, but I have to think with emerging computer learning, artificial intelligence, that is going to help this branch of the science in a big way. Have y'all started to tinker with that or explore that yet?
Yeah, so we already do machine learning. So the process by which we create our subseasonal forecasts and the seasonal forecasts by processing the dynamical models, that really is a machine learning process. That being said, the AI-based weather models has absolutely exploded onto the scene of meteorology, and we're monitoring it closely. So we have actually been running the models sort of in the background, but we're running them to compare how well they do in the subseasonal time frame. And the AI models don't yet show improved skill over the traditional weather forecast models that we would use for subseasonal forecasts. And one of the reasons is, to my knowledge, the AI-based models are not yet really forecasting the boundary conditions, meaning the sea surface temperatures, the soil moistures, and things like that. So I think there is some progress to go. But, it seems like everything in the AI world is taking about a fourth of the time that you would expect it to. So very soon here, I'm sure someone's going to publish a paper saying they've achieved improved subseasonal forecast skill from an AI-based model. So we're watching it very carefully. And when we see skill in the subseasonal time frame, that's when we'll get involved and take action.
Yeah, it's rapidly changing. That much is for sure.
Sure is.
Okay, so Jan, where can people find out more about Prescient Weather and the World Climate Service?
Yeah, so really the best place to start is our website, which is worldclimateservice.com.
Excellent. Jan, thank you so much for taking time with us today.
Thank you. It was fun.
And stay cool this summer, man.
I'll try.
All right, we'll talk to you again soon.
Thanks.
We'll be right back with some closing thoughts on the Across the Sky podcast.
McDonald's presents Burger Reviews by Hamburglar. Today's review: the hotter, juicier classic burgers. Mr. Hamburglar. Robble, robble. He said, "Of all the McDonald's burgers I've ever hamburgled, these are the hottest, juiciest, and tastiest." Robble.
Hamburglary is on the rise. Get caught with a medium double cheeseburger meal for $6. Price and participation may vary. Promotion pricing may be lower than meal price. Comparison to prior classic burgers.
Ba-da-ba-ba-ba.
Well, then, Matt, you heard it right from Jan. It's going to be hot in Texas again this year. So all your friends start texting you, is it going to be bad? You can say, yes. Yes, it is.
Yeah, I'm going to send them the link to this episode. If you don't believe me, I believe Jan, who does this stuff on a daily basis. He's focused in the long range. And, and that's when people kind of get skeptical of these long range forecasts. Like, well, y'all don't know exactly what's going to happen, 6-7 days from now. So what do you mean you're doing forecasts 3-4 weeks from now? And it's different. It's a different kind of forecasting. And we're talking, again, people kind of get frustrated with the probabilities and the confusion trying to explain those probabilities. But I like the way he explained it. And, it's the probability of, you should expect, if it's a 60% chance of above normal temperatures, well, that means above normal temperatures should happen 60% of the time, which means no, not every day is going to be above normal, but yeah, more days are going to be above normal than below normal, and it's certainly looking that way in Texas again, and that's probably a trend that's going to continue in the years ahead. There are going to be there'll be some breaks. Not every summer is going to be definitely hotter than the last summer, but an overall warming trend is where we're headed.
Yeah, it was good to have Jan on and talk about another aspect in which meteorologists are working, not in a media company like we are here. Many avenues in meteorology, and they continue to grow as the appetite for weather information increases, not only on your couch or on your favorite device, but in a professional working setting. And, we've seen it with emergency managers coming into really the limelight over the past 20 years. And what Jan is doing, working in the energy space, is another hot field in meteorology that continues to expand. And as he said, there's a growing base for it. Many of these people who are his clients are meteorologists working in the energy space. So think about it. You have meteorologists looking at other meteorologists for their information. So you kind of create this economy of weather that keeps to unfold and create these new tributaries in the main river, so to speak. So it's good for the business of meteorology, and it was great to have Jan on and talk with us all about it.
I mean, that's why NOAA's under the Department of Commerce, right? Because it is about business at the end of the day. How does the environment, how does the weather, how does the climate affect commerce and trade? And of course, not just nationally, but clearly more and more globally as well. So from global to local, let's go across my sky for this week. I will start this time. Unfortunately, we have the Dominion River Rock here in Richmond, which is the big festival we have in May down by the river, and it's going to rain. And I can tell you this, just like you, Joe, we are getting fussed at left and right because the last 3 Saturdays have been wet. This Saturday is going to be wet. And if next Saturday, Memorial Day weekend, is going to be wet, there will be even more to pay. So we've got the River Rock Festival here in Richmond this weekend, and hopefully the rain breaks enough where they can have some fun out on the river. But I'll say this, at least it's not going to be cold. Matt, what have you got going on across your sky?
Well, I've got my song of the summer, I think. What's across my sky is what's stuck in my brain. So I think I'm a little late to this. Apparently this song blew up on TikTok. But the song End of Beginning, great summer song, especially for Chicago, because Chicago is referenced multiple times in this song. And if you're wondering what summer is like in Chicago, I just say, listen to this song, End of Beginning. The artist is Joe, who it turns out I was like, I've never heard of this guy. Well, it's Steve Harrington from Stranger Things, that actor. Apparently he's a musician as well. And he came out with this song actually a couple years ago, but it blew up on TikTok in 2024. And now in May, or like February and March, I'm just now listening to it, and it's a great song. It's stuck in my head. I think it's going to be stuck in my head all summer, and it references Chicago multiple times.
I thought you said actually Joe for a second, not Joe. Was it Joe?
DJO, yeah, if you search for it. I'm assuming it's pronounced Joe. That's his alternative, his music name. It's Joe Keery, the actor, but when he does music, which I didn't know he did music, he goes by DJO or DJO.
All right, across my sky, I am going to plug our Shore Summer Weekend Weather Report Card. I am in my 7th summer of grading the summer weekends here at the Jersey Shore. It is something fun we do every summer where I literally give a letter grade to the weekends. And then in September, we do a final GPA video. So I've been doing it since we started here. The good news is every year from 2018 to 2023 has had a GPA between 3 to 3.4. So anywhere between a B to a B plus. We haven't got above 3.5. We need a lot of A's in that. Anywhere in the Northeast, it's hard to get those A beach boat weekends early on. But we're going to start it up this Memorial Day weekend. I'm hoping we can get to a 3.4. That'd be great. But I kind of said this in the beginning. We've seen all these weekends with rain here in many parts of the Northeast. And, we need the rain, of course, but maybe we can make that on like a Tuesday and a Wednesday instead of a Saturday and Sunday. That would be best.
All right, real quick before we wrap, how bad does it have to be if you get an F? Does it have to be like a hurricane?
Great question. So I have never given an F in the report card, and it's not because I'm being soft. It's because so I do Friday through Sunday. So it really has to be torrentially bad weather for 3 days in a row. We know that's hard to come by, but I'm glad you brought that point up, Sean, because I want to take you to Memorial Day 2021. Now, we were coming out of, let's say the depths of COVID in New Jersey specifically. Everything opened back up on Memorial Day weekend, but the weather was horrendous. Friday had rain late in the day, and it poured Saturday and Sunday, Sean. It poured all day long. High temperatures were in the low 50s. That was it. I was going to give it an F, but then Monday ended up being sunny and like 65 degrees. I couldn't do that, so I gave it a D+. So I've never gotten to an F, Sean. You would really need 3 days in a row of horrendous weather, but by the same token, that's why it's hard to get an A. It's hard to get A weather 3 days in a row, especially, in the Northeast. Same thing for Chicago, right, Matt? I mean, it's hard to get 3 days of perfect beach weather in a row. But we'll see. Maybe we'll get surprised and hopefully we don't have any Fs, but if we do, that would be news. And maybe we can get above a 3.5 GPA and get us closer to A territory.
But if you have a hurricane that hits just 1 day out of the weekend, would that qualify as an F, even if it's just a 1 day event?
It would be hard for me to give an F. That's all. That's all I'm saying.
You're a kind man.
Maybe I'm soft. Soft.
No, you're from Jersey, Martucci. You're not soft. You're a good mad dog. We appreciate it. All right, let's wrap it up for this week. Speaking of Memorial Day, next weekend, Memorial Day, travel, all that stuff, we are delighted to have on Jen Carfagno from the Weather Channel. She will be joining us to talk about traveling, more specifically, these quick road trips that she has to go on to cover big-time weather. Pack your bags. You're going to the Sierras in the morning. Pack your bags. You're going to Punxsutawney. It's going to be cold. You got to cover the groundhog. So we're going to talk to her about her travels and share some of those great stories for this Memorial Day weekend podcast. Getting into June, we have Jason Oken talk about flash drought. Then later this summer, we're going to talk about summer heat and home runs in the major leagues. And then as we get into July, that's the anniversary of the Battle of Gettysburg. John Neese from Penn State is going to join us and talk about what the weather was like there at the Battle of Gettysburg in July. The short version, it was brutally hot and humid on top of everything else that was going on. So that's going to close it up for this week. As always, thank you so much for listening to the Across the Sky podcast. And if you like it, take a moment, rate and review us. Those things always help in the big bad algorithm, and share wherever you can. So for Matt Holiner and Joe Martucci, and for Kirsten Lang out of the office this week, I'm meteorologist Sean Sublette. Thanks for listening to the Across the Sky podcast. We will talk with you next week.
McDonald's presents Burger Reviews by Hamburglar. Today's review, the hotter, juicier classic burgers. Mr. Hamburglar. Rubble, rubble. He said, "Of all the McDonald's burgers I've ever hamburgled, these are the hottest, juiciest, and tastiest." Bravo.
Hamburglery is on the rise. Get caught with a medium double cheeseburger meal for $6. Price and participation may vary. Promotion pricing may be lower than meal price. Comparison to prior classic burgers.
Ba-da-ba-ba-ba.